and for Phase 1 of the design project, we'll be looking at the Ojibway community of Grassy Narrows, specifically in the context of clean water. The Ojibway First Nation community inhabits northern Kenora in Ontario in the English River Indian Reserve number 21. To identify the user needs, my team and I will take a closer look at the environmental disaster which occurred at the Ojibway community of Grassy Narrows. The long-term drinking water advisory related to this issue had recently been lifted, lasting 2013 through October 2020. This was due to the result of mercury poisoning into the Wabigoon River. This dates back in 1960, where the Dryden Chemical Company dumped its wastewater containing approximately 9 to 10 tons of mercury into the nearby river. This eventually entered the food chain, accumulating in wildlife and being part of the diet of First Nations such as the Grassy Narrows. This problem is an example of causing pain, which led to generations of physical, social, and economic suffering, and is still present decades later as small concentration of mercury exists in the river. My team and I have narrowed our focus on the clean water aspect of this issue, as tap water is still deemed to be unsafe in the Grassy Narrows First Nation Community Reserve, affecting 1,500 members every day.
Attributes of our project. The goal. The goal of our project is to provide clean and sustainable water to the Indigenous Ojibway community of Grassy Narrows. The function. The function is to remove mercury contamination from the Ojibway community of Grassy Narrows water supply. The objective. The objectives of our project is to be effective at neutralizing mercury. It should be a safe process that should cause no harm to the community members or the workers attempting to clean the water. It should be a reliable approach. The process should be able to neutralize the mercury to at least a non-toxic concentration. Some constraints is that our project should be environmentally friendly. It should cause no harm to marine life or wildlife surrounding the water. Some limitations are that since the water supply is so large, it will be difficult to neutralize the mercury. Another limitation is that the Canadian government has shown little initiative in funding clean water solutions for Indigenous communities. So our implementation of our plan is a 4-step process of filtering, guarded, activated carbon, lime softening, reverse osmosis. This will neutralize the mercury. And at the end of that, we're going to have a water security check to ensure that the water going to the members of the community is mercury-free.
Our ideation method and research involved a few steps. We began with a group discussion to decide our topic based on a challenge that we would enjoy attempting to solve. We shared our ideas and theories on the issue, then derived a research plan, which involved mostly researching credible secondary sources, using the internet and the York U Library. Once we collected our data information, we reflected on our theories to see what differed between our speculation and the truth. And lastly, we organized our data to present it in an impactful manner.
Here I'll be talking about the evidence and problem formulated by mercury contamination in the Wabigoon River and how it's affecting the native Ojibway community nearby. Residents in Grassy Narrows cannot drink water from the tap, thus they have to buy bottled water every day because of mercury contamination, which is caused by dumping 9,000 kilograms of mercury in Wabigoon River in the 1970s. Nearly 60 years later, the water is still poisonous as it bioaccumulated throughout generations. Due to the ineffective and non-existent water treatment system, even the Canadian government admits that waterborne diseases are very common in First Nation communities. Mercury poisoning is a very common symptom that 90% of people in the community face, and many suffer with neurological and severe problems. People from community feel like being poisoned. Also, the skin diseases are very common in people because of the exposure to mercury while bathing because of the poor and contaminated water.
Our initial problem statement is the following. For generations, the Ojibway community of Grassy Narrows has been experiencing tragedy after tragedy in their community, and this can all be traced back to unclean water. 90% of the community members have been undergoing neurological problems such as seizures, loss of feeling in toes and fingers, and cognitive delays. These are all signs of mercury poisoning and have led to other psychological effects on surrounding family members. In the 1960s to 70s, over 9,000 kilograms of mercury were poured into the English Wabigoon River by the Reed Paper Mill in Dryden, Ontario. The river, which provided a source of drinking and a location for fishing, was contaminated, unknowingly to the Ojibway community. In addition to the health problems caused by the water, this negatively affected the fishing tourism industry, causing mass unemployment and a large increase in alcohol abuse among those in the community. With the mercury poisoning, poisoned supply water, many problems have arose in the community, leading it to be a root cause that must have a sufficient solution in order for the community to succeed in future generations.
A successful project would look like providing clean water to the Ojibway community by cleaning and decontaminating their mercury-filled water supply. A successful implementation of a trusted water decontamination method should be put into place, such as reverse osmosis. In reverse contamination, water is forced through a semi-permeable membrane using a high-pressure pump. This filters the water, leaving 95 to 99% of all dissolved salts behind the membrane. This is a fairly expensive process, however, it removes the most contaminants compared to other common water disinfection methods. This method is also very environmentally friendly compared to other methods as chemicals are not added into the water. By the help of the government funding, we will be able to install a semi-permeable membrane into the infected water and filter it slowly. For this project to be successful, Constant monitoring of the filter would be required, and proper execution to properly dispose of the water waste would be put into place.